I think I've got it now.
Ooh, it's slides tonight, huh?
Yes, indeed. Tonight is multimedia night. David's going to be by later on with some more equipment.
Well, one picture is worth 1,000 words.
Yeah, he probably brought more than one picture.
I imagine we're going to hear a lot of words, too.
Would somebody
Yeah.
get the lights back there? Now, David brought us these slides, but the tape narration that came along with them is really crummy. We can do a whole lot better ourselves.
You expect us to make up narration for slides we've never even seen?
Well, why not? I think that's what the original writers did.
Not bad, huh?
Well, it's got some good points, but we really can do better.
What's it about?
It's about number theory. What do you think this one's about?
Counting to 10.
Really?
Maybe it's about how our number system revolves around 10.
Sure, that's it. You know, a lot of people think that if we had a different number of fingers, our entire number system would be different. Fingers are called digits, you know.
Oh, I get it, because numbers are called digits sometimes, too. Is this one of those chicken and egg questions?
You mean which came first?
Right,
Yeah.
do we call numbers digits because we count on our fingers, or do we call our fingers digits? Well, you see what I mean?
Yeah.
Frank, how about that?
Well, let's look at this next slide.
Notice every time Frank can't answer a question, he goes to the next slide or
Yeah.
page or
Or
problem.
when we don't know a question. Oh, a
Yeah.
number line. I bet you and David like this one.
Okay, now, if you were going to tell somebody how that first slide related to this one, what would you say?
Well, it's probably because we count to 10 and then we start over again.
Start over?
Well, after we've counted to 10, then we start counting the number of tens and what's left over.
That's right, Todd. It's called regrouping.
Of course, we know that this just represents an idea. I mean, we can't really see a number line.
Anybody that's been around David has heard that record over and over and over.
Abstract and concrete.
That's what he says. It's just a way to make an abstraction something you can touch.
That's right. All right, now, what would you tell someone about this slide?
Oh, now this bottom line, it's like you've magnified the part of the number line from 0 to 1, and then it's been divided into 10 equal parts.
You mean this is that infinity idea again?
It must be. If there are as many divisions as you want from 0 to the end of numbers, and they can be grouped in 10, the same thing can be done with the space between 0 and 1.
But why 10?
Well, so you don't change the system. It's the same.
Yeah, and that way you can regroup in tens until you get to 1.
Now you've got it. Decimals are just an extension of the whole number system, right? Okay, anything else before we move on?
Well, I suppose it shows that decimals always have a denominator of 10.
You know that's exactly what their tape narration says. Okay.
Oh, I know what this is. This is that magnifying glass idea again, isn't it? The third line is a small segment, 1/10, taken from the second line, and they've cut it up into 10 pieces so that it's become hundreds.
That's right. Now, why is that important?
Well, it shows that each piece is 1/10 the size of the previous one, so you can multiply or divide to go from one to the other, depending on which way you want to go.
You know, 100th isn't a very big piece.
Well, now that depends on what you cut up. Well, if you cut up a whale, that's a pretty good sized piece.
What's next?
Place value.
Well, what can you say about this one except that it shows that the decimal point goes between the ones column and the tens column?
Well, one other thing is that every number has a decimal point in it.
It does?
Well, sure. Can you think of one that doesn't?
25.
No, that's called decimal understood, because that decimal is there whether we write it in or not. Well, let's go on. Maybe this other idea will come out more clearly as we go along, okay?
Oh, another place value chart. No excitement there.
Well, now, there might be. Look at that first number. Who'd like to read it for us?
It's 125 and 333,000.
Yes, that's right. There is no excitement there.
If you hadn't said that "and" in the right place, it would have been a lot of excitement.
You're absolutely right, Bill. Look at this.
You've told us that so many times I've dreamed about it. Never say the word "and" until you get to the decimal point.
Well, it's very, very, very important. Here, read these.
25 and 1/10. 35 and 1/10.
Very good. All right. Now, Todd, pretend that you're a narrator, okay? What would you be telling us about this slide? Tell us as much about it as you can.
Well, all right. Here we have the number 25. That stands for 2 10s and 5 1s. Now, the decimal point, which usually isn't written with a whole number, means there is nothing else. It is exactly 25.
Go on.
Well, if you can assume that there's a decimal point and not write it, then you can imagine that there are a lot of zeros extending in both directions from the number.
That's good, Todd.
Yes, very good. Martha, you try one.
Me?
Yes, here, try this.
Okay, I'll try. Where the decimal point is tells us how big the number is going to be. If you have the number 25 and you move the decimal point over one place to the right, you get 250. Every place that you move the decimal point to the right makes the number before it 10 times bigger than before.
Absolutely right. See, you can do it. Okay, Bill, you do this one.
Well, if we start off with a number like 25 and move the decimal point one place to the left, it's like dividing. If you divide 25 by 10, you get 2 and 5 tenths.
Yeah, that's right. He knows where to put that "and," so I won't yell at him, right? What happens if we move the decimal point 2 places to the left?
Well, that's like dividing by 100.
Like that.
Right.
All right, Sue, you get this one.
Well, 2.5 expressed as a common fraction comes out looking like this, but written as a decimal, it's 2.5 tenths or 2 50/100ths.
All right, good. Do the next one too, Sue.
Okay, changing 3 1/4 written as a decimal gives you 3 25/100ths.
Good. All right, here we have an addition problem. What do you think?
Well, you keep the decimal points lined up. It's the only way you can be sure that you're adding the same kinds of things together.
That's right. Now, the only thing we haven't talked about is how to read a decimal. Now, who can give me a tried and true method to read them?
Well, I just read the number as it is, and then I give it the name of the last column. I mean, if there are 2 numbers to the right of the decimal point, then I read it as it is, and then I say the word hundredths.
Well, I know what you mean, but I'm not sure that's clear.
But that's the way I do it.
Well, maybe this will help you explain.
Oh, yeah. Okay, so take a look at A. It looks like 44, but the last 4 is in the hundredths column, so I say hundredths.
Good. All right, what about the next one?
It's the same. It looks like 3, so I say 3, and then I say hundredths, so that's 300.
And the next one?
That's 100 300,000.
You guys think that's all there is to this, huh? Well, you're probably right. I wish I had a tape recorder, you know, because your comments were a lot more concrete than the commercial narration.
Uh-oh, we're sneaking some vocabulary in here, class.
And he certainly wasn't very abstract about it.
Well, let's see if this slide is abstract enough for you, Todd.
Pretty abstract,
Hey, let's take a break for a little while. I think you're all really going to like this next part that we have planned.
What is it?
Okay.
All right.
Well, as long as it's different from this.
Hi, I'm Steve Wise, and I'm here to go over some important points to remember from what we just saw. Decimal fractions are an extension of the whole number system. Decimal fractions have denominators that are always 10 or powers of 10. Powers of 10 means 10 times 10 times 10 times 10, etc., like this. 10 to the second power is equal to 10 times 10. 10 to the third power is equal to 10 times 10 times 10, etc. Always remember that when reading a number, be sure to say "and" only when you get to the decimal point. You should remember from the slides that a decimal fraction takes the name or denominator of the column of the last digit to the right. Here's another example. This equals 3 78/100ths. Here are some vocabulary words you should be familiar with. Abstract, which means not easily understood or imaginary. Concrete, which means actual, existing in reality. Point understood. When you write a whole number, you usually don't put a decimal, even though the point is understood to be there. Now, if you understand all of that, you're doing fine. Let's get back and see what Frank and David are up to.
Nothing to it. Picture's in here, recorder's right over there, and the monitor's right up there.
Good, okay. Hey, watch this. Smile! You're on you know what.
You guys doing now?
We're going to make TV stars out of you guys tonight. Oh, here comes the rest of the cast. Good. How long is this going to take, David?
Shouldn't take any longer than it takes to work the problems.
Yeah? Well, we better get started then, because I know they're going to want to see the tape when we're finished.
What's going on here?
Oh, I'm going to start a new class on Tuesday night, and I want to use you to help me to teach them how to operate with decimals, okay? David's going to shoot some videotape of you working some problems using decimals. There won't be any sound. He's just going to shoot some pictures of each of you solving a couple of problems.
Can we see this when we're finished?
What did I tell you? Of course you can.
Thank you.
Good. We better get started right now, though, so we'll have time enough to make the tape and then view our handiwork. Huh? Todd, do you want to do the addition problems?
Sure.
Okay, and Sue, you can do subtraction.
Okay.
And Bill, you can multiply, and Martha can divide.
Okay, I'm game when we begin our debut.
Okay, now to avoid moving the equipment, why don't we just go one at a time up here and sit at the desk, okay, where David's already got the equipment set up. Todd, come on up and let me give you a couple problems. David, are you set up?
Let's go.
Okay. Todd, right up there at the top of your page, addition of decimals. Write it fairly large, good, so people can see it. Good. Okay, now add these numbers. 46 and 234 thousandths plus 25 and 56 hundredths.
Oh,
Good.
he's lining up the points just right.
Good.
I do believe he knows what he's doing.
But can he add?
Good.
Oh,
Yes, you can.
yes, he
Good,
can.
Todd. Okay, move your paper up a little bit and now write this down, okay? 236 and 3 thousandths plus 19 and 948 thousandths. That's good. He's writing it neatly so people can see.
You remember how much trouble I had when we started this? I could never remember to put those zeros in there so that the 3 would end up in the thousandths column.
I remember you called me every night for 3 weeks, and I kept saying, put the number in the column that gives it its name, and fill up the other columns with zeros.
Well, you weren't always so cheery.
I'm not cheery at 12 o'clock at night, Martha.
All right. Now, Frank, he's got the right answer. Do you think your new students will be able to follow what he did?
That's a good point. See, what I'll do is narrate this tape and explain what he's doing as he goes along, so they can see how carefully he's lining up the decimal points and how he gets the point in the right place in the answer. You know, the whole story. Okay, Todd, good, good. David, shut it off and let's trade actors.
Okay, Sue, come on down.
All right, Sue, this
Okay.
Oh, thanks. I love your face in there.
Okay. Everybody ready?
Yeah.
Sue, write subtraction of decimals. Good. Okay. Now write this problem. 36 and 19 hundredths minus 12 and 46 thousandths. Good. Good. Don't take any shortcuts. Write down every step. That's right. Show how you borrow from the 9.
You know, that was fun. I think I found myself a new career.
I don't think the ratings would be too high. You know, you may have just completed your entire TV career.
Well, then I'll just have to make a comeback.
That's good. So move your paper up a little bit and let me give you another one. Okay. 863 and 5 tenths minus 233 and 9 tenths. Now that should demonstrate the borrowing procedure.
Now, what are you going to do if we make a mistake?
Well, that's the beauty of tape. We'll just do it again till you get it right.
Oh,
Good.
You're all night.
Good, Sue. Good. Okay, David, shut it down and we'll trade Bill for Sue.
Oh, boy. All right. Wish me luck, folks.
Okay.
David, tell me when I've got this lined up about right.
Okay, looks good right now, Bill.
Okay, write multiplication of decimals at the top of the page. Then write this problem. 26 and 1500ths times 6 and 4/10.
Look at him go, ladies and gentlemen, lined up in the right on the right side of the line there. What a mathematician he
No
is.
heckling from the audience, please.
Did he
It's
come-
hard enough to do this without your help.
Good, good,
Good.
good. All right, good. Okay, on this next problem, Bill, write the numerals just a little bit larger. I think they'll be easier to see on the screen, okay? You ready? All right. 68 and 1400ths times 3 and 8/10. Good. Yeah, good. Now this time, make sure that we understand how you know where to put the decimal point in the answer.
Okay.
Actually, take your pencil and go
I
back
got
up
the
there and
idea.
count the
Right.
places. In the multiplier and in the multiplicand, that's good, yes, and in the answer. That's good, Bill.
Was it that funny?
You've got a real flair for this. Okay, Martha,
You can
you're
do it,
up.
Martha.
All right, now be sure you show every step, okay?
I'm ready when you are, Martha.
Okay, all set.
All right, now write division of decimals. Now, it is really very important that you show every step in this process. Okay?
Okay.
Divide this. 24 and 8/10 divided by 2 and 2/10. Move the decimal point in the divisor, good, and in the dividend, and divide. Good. Good. Express the remainder as a common fraction, and you'll have to reduce it, all right? Good. Good. That's good. That'll show that things don't always come out even and what to do about it. Okay, you ready for another one?
Okay.
All right. Do this. 3400ths into 25. That should show the importance of zeros and place values. That's good, Martha. Good. Good. Equals. Good, Martha. Very good. Good, good. All right. Okay, that takes care of all 4 of the operations. Shut it down, David. Rewind it. We'll look at our production, okay? And while we do that, will you all think of whatever suggestions you have to help me with my newcomers?
I'm ready when you are.
Okay, let's see it.
Okay.
Now I can tell right off what the message is in addition and subtraction. Keep the decimal points lined up, one right over the other. No matter how many numbers you got, keep that darn thing in place.
Now that sounds good, but what do I tell my students when they ask why?
Well, then you just have to explain place value to them. I mean, they got to see that when they line the points up, they're adding and subtracting from things that have the same value. You know, ones to ones, tens to tens, tens to tens.
Oh, look, there I am.
Now, is there anything else I should tell them about subtraction?
Yeah, they need to be careful when they're borrowing. A mistake there could make them look good.
Mm-hmm. Anything else?
Oh, I'd like to put enough zeros on the end of my short numbers just to even up the right side. I know it's not necessary, but it helps my thinking.
Ah, here's Bill's.
Now, what's the secret here?
Well, make the numbers even on the right side, and you have to be sure to count the places to the right of the decimal point, and make sure you count off the same number of places in the answer.
Why does that work?
I have no idea.
Well, that might be a good thing to fool around with that and see if you could figure out why.
Well, I guess I could figure it out. Look, see, I can put it in there.
I bet you can.
Okay, you guys, let's concentrate on my performance.
Performance. Get her.
Isn't division the hardest operation to explain?
It needn't be, but yes, it is. If people would just remember to move the decimal point in the divisor to make it a whole number, and then do the same thing to the dividend, there wouldn't be any difficulty. Good. Well, this tastes very good for a first try. I think I'll get a lot of use out of it. Well, let's take a break now, okay? We'll probably win an Emmy for this.
Here are some points to remember about decimal points. To add or subtract a decimal fraction, be certain that all the decimal points are lined up under one another. Notice the decimals in these examples. Be sure to put the decimal point and the answer right under the others. Now, to multiply by a decimal fraction, set up the problem so that the right side is lined up as in this example. To place the decimal point in the right place in the product, count the number of places to the right of the decimal point in the multiplicand and the multiplier, and count off the same number in the product. Now, just as a challenge question, let me ask if you know why this works. I'll give you a clue. What is 1/10 times 1,000th? Think about it. There is one more point about decimals that you must remember. Move the decimal point in the divisor enough places to make it a whole number. Move the decimal point in the dividend the same number of places. Annex enough zeros in the dividend to allow you to do this. After the point is placed, if you need to, carry the problem out farther. Annex still more zeros. Enough about decimal points. I'll see you later.
You know, you can't pick up a newspaper nowadays without seeing a graph of some kind. Now, often a circle graph is used to depict the whole quantity being discussed or a representative part of the whole thing. Now, we'll pretend that this represents $1 of a particular budget. Now, it assumes that every dollar in the budget is spent the same way, proportionately at least. Now, since a dollar is 100 cents, an interesting decimal relationship can be shown. This is a picture of a budget for a club, say the Grand Order of the Mystic Poobah. Now, all the money they take in, that's this whole circle, can be represented by thinking of just $1 and then deciding how each portion will be spent. If we know that 26 cents of each dollar is spent for rent, what else do we need to know to find out how much their rent is totally?
Well, if you know how much money they have in the total treasury, then it'll be easy to figure that out.
How so?
Well, if they have $1,000 and they're planning on spending each one the same way, then 1,000 times 26 cents will tell you that how much rent they pay.
Right. Does everybody agree with that? All right. Now I want to change the picture just a little bit. Is this graph like the last one?
Yeah, it is, except that the figures are expressed as fractional parts of a dollar. 16/100ths of a dollar is 16 cents.
Now, can you find the total spent for utilities from that? Obviously, they spent more for utilities than 16 cents.
If their utilities bill is anything like mine, I guarantee that they spent more than 16 cents. Well, I think it's like Todd said. You have to find out their total budget, and then you multiply it by 0.16.
Right. Now, very often, these pie graphs will use these same items in percents. Now, since percent means out of 100, the picture can look the same, but this makes the calculation a little different.
You have to realize that 16% is the same as 1,600, so you just put the decimal point back in and multiply, like Martha said.
Well, now, in that case, tell me about 5%.
Well, it's the same thing. 5% is 500ths. Now, to make it read 500, you have to put a 0 in between the decimal point and the 5, so that the 5 goes in the hundredths column.
That's right, right. Okay, folks, that's the purpose of this kind of graph. It is a pictorial representation, so you can quickly see something about the situation, but if you want more information, you can find it out. Okay? Here's another kind of graph called a bar graph. Now, this one tells about the imports of various raw materials. Again, you can see something about each one at a glance and compare them with each other. Now, this one is listed in percents, too. From looking at this, can you tell how much petroleum is imported?
Well, do we know the total amount that's being used?
A bunch.
But Todd, you can't have 42% of a bunch.
Well, it seems to me that I read somewhere that we use about 7 billion barrels a year.
So that would mean that we need to change 42% to 4,200th times 7 billion barrels.
That's right, and then it's simple arithmetic from there on. Now, simple line graphs are a lot like that graph up there. They're set up on a vertical and a horizontal axis, too. This is a way of looking at more than one thing at the same time. Now, look at this On the horizontal axis along the bottom, we have the month of the year. And on the vertical axis is the number of chairs sold by a manufacturer. Now, this tells us how many chairs they sold in any month. So, how many chairs were sold in the month of March?
That looks like about 6 3/4 chairs.
Well, what good is 3/4 of a chair?
Well, it doesn't mean 3/4 of one chair, it means 3/4 of 100 chairs. See down at the bottom where it says chairs are listed in hundreds?
Yeah, I saw that. Now, my question still stands. How many chairs did they sell in March?
Well, there's several ways of working it out. You can say that 3/4 of 100 is 75, so that would be a total of 675. Or you can say that 6 3/4 is 6.75, multiply by 100. Now, if you want to, you can just move the decimal point 2 places to the right. That's the same as multiplying by 100. And again, the answer is 675.
Right. Now, this proves what I've said all along about decimals. They are very nice to work with. All right, here is another line graph. Now, the nice thing about a graph like this is the ease of reading amounts that fall in between the reference points. How many gallons can flow over this dam in 4 days?
7.
Only 7? That's not much of a dam.
I see. Each number stands for a million. Oh,
Right.
okay. Well, then that's 7 million flow over it in 4 days.
Now, I use this graph for another purpose, too. It's an interesting one because the line is straight. I guess that's the nature of water. This line indicates that there is a constant flow of water, and the longer it flows, the more it goes over, and at the same rate. Now, who can tell me exactly how much water flows over the dam in 1 day?
If it does 7 in 4 days, isn't that 7/4 in 1 day?
Indeed it is.
So if I want to find out the amount in 2.5 days, couldn't I just multiply 2.5 times 7/4?
Yes, you could. Turn off that projector. Somebody hit the lights back there, would you? Let me work this out for you here on the board, and then I'm going to try to give you something to think about. 7/4 times 2 1/2 is the same as 7/4 times 5 over 2 is 35 over 8, or 4 3/8. Okay? Now, between now and the next time we meet, see if you can invent a way to discover the something in this equation. Okay? Write it down, and then let's get out of here. See you all next week.
Okay, bye-bye.
I'm back, and I've got a couple of things you need to remember about graphs. A graph is a pictorial way of showing quantitative or numerical information. Graphs give a quick idea of a situation. Many graphs talk about more than one thing at a time. They will enable you to make comparisons that would otherwise be very difficult to express. When reading graphs, always be sure to look for the key to see how much the various increments are really talking about. Until next time, this is Steve Wise saying so long.